So in this video, we're going to look into infinite limits and vertical asymptotes. So we're given the limit as x approaches 5 from the right-hand side of the function x squared plus 1. So this is asking us for a one-sided limit, right? As they're asking us the limit as 5 approaches from the right-hand side. So we say that when we approach a number from the right-hand side, that means that we are almost at that number, but we are slightly on the right side, meaning that we are slightly greater than that number. So as x approaches 5 from the right hand side, so we are taking if x is equal to 5.1, the y value is 27.01. If x is now more closer to 5 from the right hand side, y is equal to 26.1. When x is 5.001, y is equal to 26.01. And finally, when x is almost 5, right? It's very, very close to 5. When x is 5.0001, the y value is 26.001. So like we just discussed in the numerical approach of calculating limits, we know that as we're approaching 5 from the right hand side, the y value is getting closer and closer to 26, one particular number. Hence, we can say that this limit is equal to 26 because as x gets closer and closer to 5 from the right hand side, the y values are getting closer and closer to one particular number, which is 26. Now let's look at the second example over here. So this is the limit as x approaches 0 from the right hand side of 1 over x. So again, we're approaching 0 from the right hand side. So the values, the x values that we take are going to be slightly greater than 0. So when x is 0.1, y is equal to 10. When x is 0.01, y is equal to 100. When x is a lot more closer to 0 now, 0.001, y is equal to 1000. When x is 0.0001, y is equal to 10,000. So as x is getting closer and closer to 0 from the right hand side, is y getting closer to any specific number? In this first example over here, y was getting closer to one particular number, which is 26, right? But in this second example over here, we can see that as x is getting closer and closer to 0, y is just getting larger and larger. It's just getting bigger and bigger. It's not approaching one specific number, right? So whenever we have this sort of a scenario where y doesn't tend to approach any one specific particular number, but instead it just keeps on getting bigger and bigger as we approach that number, or even if it gets smaller and smaller as we approach that number, we can say that y approaches infinity. So in this case, what we can say is that the limit as x approaches 0 from the right of the function 1 over x is equal to positive infinity. Now what does this mean? So this tells us that as we're approaching 0 from the right hand side, the y values are getting bigger and bigger without any particular bound. So they are not approaching any single particular number, but rather the y values are getting bigger and bigger. So this is simply what the limit of positive infinity means. So now let's use the same example but approach 0 from the left hand side. So as we're approaching 0 from the left hand side, that means that our x values are going to be slightly lesser than 0. So when x is minus 0.1, y is minus 10. When x is a lot more closer to 0, y is minus 100. Then when x is minus 0.001, y is minus 1000. And when x is minus 0.0001, y is equal to minus 10,000. So in this case, as we are approaching 0 from the left hand side, the y values again are not tending to approach any particular number, but rather the y values are getting bigger and bigger in the negative direction. So in reality, the y values are getting smaller and smaller, right? So in this case, what we can say is that this limit as x approaches 0 from the left hand side is equal to minus infinity. What this means is that as we're approaching 0 from the left hand side, the y values get smaller and smaller without any bound. When the y values are getting bigger and bigger, we say that the limit is equal to positive infinity. When the y values get smaller and smaller, the limit is equal to minus infinity. So in the examples that we just saw, we could make a few observations. So we saw that when x approaches 0 from the right hand side, y doesn't tend to approach any one or any specific number, right? It just keeps on getting bigger and bigger. And since it keeps on getting bigger and bigger, how we can represent this or how we can show this is that we can say that the limit as x approaches 0 from the right is equal to positive infinity because it gets bigger and bigger. That's why we say positive infinity. So when a limit is equal to positive infinity, it means that as x is approaching that particular number, y is just getting bigger and bigger. It doesn't tend to approach any single number. Now, when x approached 0 from the left-hand side, we saw that again, y didn't tend to approach any specific, right, any single specific number. Rather, it just kept on getting smaller and smaller. It didn't approach any number and it kept on getting smaller and smaller. So in that case, we say that the limit as x approaches 0 from the left hand side was negative infinity because y kept on getting smaller and smaller. So whenever the limit as x approaches a particular number is equal to minus infinity, that means that as x approaches that number, right, the function or the y value just becomes smaller and smaller. It doesn't approach any particular number, but it just becomes smaller and smaller as x approaches that number. Now, one very important thing to note is that we know that the function is 1 over x. Right now, if we are supposed to find the y value, not the limit, but f of 0, which is the y value when x is equal to 0, that is basically going to be undefined. So the question that comes in mind is that why on earth is that undefined? Remember, infinity is not a real number. Infinity is like a concept, right? We cannot represent infinity inside a graph. A limit of infinity just tells us if y is getting bigger and bigger or smaller and smaller as x approaches a particular number. The concept of limit does not consider the case when x is equal to 0. We are talking about when x approaches 0. Now, what exactly happens at x equals to 0 is where we come into the function part of it. What is f of 0? So, what this tells us is the y value when x is exactly equal to 0. Now remember that infinity is not a real number. We cannot represent infinity in a graph. Hence, when we are told to find f of 0 when the function is equal to 1 over x, f of 0 gives us 1 over 0, and this is undefined because we cannot represent infinity on a graph. However, as we just said, the limits can be equal to infinite. So this just tells us whether if x is getting bigger and bigger as we approach a number or if it's getting smaller and smaller. But the function itself cannot equal infinity because infinity we cannot represent on a graph. Infinity is undefined. It's not a real number. That's why f of 0, right, or 1 over 0 is equal to undefined. Okay? So now finally, let's have a quick look at the graph of this function 1 over x. So as we just said, the limit as x approached 0 from the right was positive infinity. So we can see in this graph, as we are approaching 0 from the right hand side, right, as x is getting closer and closer to 0 from the right hand side, the y values just tend to get bigger and bigger, bigger and bigger, right? So even if I zoom this out, you can see the y values just tend to get bigger and bigger and bigger and bigger. They don't tend to approach any particular number, right? We also said that the limit as x approaches 0 from the left hand side was negative infinity. So that means that the y values are getting smaller and smaller as x approaches 0 from the left hand side. So again, if we go down, we'll see that the y values are getting smaller and smaller, smaller and smaller as x approaches 0 from the left hand side. Now, one very important observation that we need to make over here is that if you look closely, you will see that the graph is never going to touch the value that x is approaching. In this case, the graph never touches or never crosses x equals to 0. So let's zoom this in a little bit. So you will see that regardless of how close to 0 I'm getting, the graph is never, it's coming very close to x equals to 0, but it's never touching x equals to 0 or it's never crossing x equals to 0. Regardless of how much I zoom in, you'll see that the graph is never going to touch x equals to 0. In a similar way, as we approach 0 from the left hand side, the same thing happens. The graph does not touch x equals to 0. Right? The graph is not touching x equals to 0. See, if I'm zooming in, it's not touching x equals to 0. Why the graph is not touching x equals to 0 is because recall that we said that f of 0 is undefined. That is, when x is equal to 0, the y value exactly when x equals to 0 is undefined because infinity is not a real number. We cannot show infinity on a graph. So this imaginary vertical blue line which the function never touches is what we call the vertical asymptote. It's very important to understand this. So, whenever the limit equals to infinity, be it positive infinity or negative infinity, then the value that x is approaching is a vertical asymptote. In this case, we know that the limit as x approaches 0 from the right is equal to an infinity. So, it's safe to say that x equals to 0 is a vertical asymptote. So for this given example, both the one-sided limits are infinite, but as long as any one of your one-sided limit is infinity, it is safe to say that there exists a vertical asymptote at that value which x is approaching. The graph or the function will never touch nor cross the vertical asymptote. This is very important to remember.